Okay, so this the task using a proportional control, program a wheeled mobile robot to drive around an equilateral triangle. So the robot should cover a distance of exactly 1 meter on each side in exactly 5 seconds, irrespective of obstacles that may get in its way. In the presence of an obstacle, the robot should wait for the obstacle to clear, then continue its motion. Total motion must be 50 seconds. If for whatever reason your robot spends more than 5 seconds on the side, or I should add in this case, if it spends less than 5 seconds on the side, you should make up for the lost time or take the lost time on the excess time or the deficient time on the next side to ensure that the total time is 15 seconds. So the task is pretty simple. Get your robots to move around the triangle, equilateral triangle of 1 meters, and spend 15 seconds doing that. So that's what we're going to do. We're going to write the code, then we're going to see how it works. Okay, this is the code. It's a modification of the previous code I uploaded as a PDF. Just going to scroll from the beginning to the end, then talk a little bit about some parts. Okay, scrolling. Yeah, about 300 lines or something. So scrolling. And that's that. So going to the top things I think should deserve a mention. This variable here, number of slots. Here I'm using a value of 20, and I'm able to use this value, which is the number of slots I will encode this class earlier. I'm going to use this value because I connected a 100 nanofarad or 0.01 microfarad capacitor between the D0 pin and the ground pin of my optical speed sensor. If you didn't do that, or if I didn't do that, I might have had to use a value of 80 here to get some accurate value with my distance. I also have a calibration value. This value is specific to my robot, and I multiply this value with the distance per tick. So my robot moves, say 1 meter. When I tell it to move 1 meter, it actually moves 1 meter, not less than 1 meter, not more than 1 meter. And everything else is pretty standard. Yeah, I have a minimum turning speed. That's when I'm turning left or turning right. This is the minimum speed at which you turn, and could go as high as, well, go as high as maybe 70 something, depending on the turn, the angle it has to turn. Then yeah, everything else is straightforward. And yeah, over here when I attach interrupt, I use the value rising. So I only wanted to raise and interrupt when the output pin, the T0 pin for the speed sensor goes from low to high. That's that may be when, I think that is when the disk moves from the whole to not whole or something. Anyhow, so the proper value is either rising or falling, but not change, rising or falling. So the real big difference between this function and the last one I uploaded as a PDF is in the adjust speed function. Here I did a little bit of serious modification, rather. I did some modifications. So what I did is that every 2 ticks I calculate the speed, average speed taken between the last 2 ticks. Like I find the distance traveled in 2 ticks, then I find the time it took for that distance, then I take the ratio of the distance to the speeds, and then that gives me the actual speed of the vehicle. Then I calculate my desired speed by taking the ratio of the distance left over the time left. Then I use some mathematics to compute the new speed. Like I take the desired speed to the actual speed, and I find the PWM I need to send to the motors to move from the desired speed to the actual speed, and I constrain this value so it doesn't go below 65 and doesn't go above 180. Then I reset the time, travel time at the last speed estimate, and also the number of ticks. So whenever I get a pulse from my encoder, I also increment the number of ticks by since last speed estimate by 1. Then I also make sure that I only adjust speed if I've gotten at least 2 ticks. So if number of ticks since last video estimate is less than 2, this function doesn't do anything, the function returns. So yeah, it's pretty straightforward. Feel free. Yeah, I am not going to drop the .ino file of this code. That's just what I do now.